Welcome to the Fine Print, ladies and gentlemen. I'm your host, Caleb Teskey. And believe it or not, I've got another fantastic guest for you today. And believe it or not, I'd also like to thank a couple of my previous guests here. Had a great show the other night with the old man of the mountain, Charles Stockstill, talking about the Gantier program and his experience getting raided multiple times. Yeah, pretty great stuff there, Charles. I had Tara Evelyn on, the Herbal Creative. We had some great discussions as well about the work that she's doing. I'm still trying to get to Steve Robinson about this story about the illegal grows being taken over by the Chinese in Maine. He hasn't got back to me, but I'd really like to get Steve on still. And had a great chat with my graphic designer and fantastic human and comedian, Brianna Woodward. And I do want to do a couple upcomings here. I got Miguel Lopez on Thursday from LB Farms here in Vermont. I'm psyched to have Miguel back on again. He was here last year. Then on Saturday, I got Jason Struthers. And if you haven't heard this guy's story, you're really going to want to tune in for this. And then, coming up next week, I got Ben Gruno, who filmed the interview I did with John Rogers last year. And I've got Summer Westerberg, who I connected with on LinkedIn after some of her comments about what happened to MJ Biz. And that's about all the time I'm going to waste here. I know my guest tonight has another show to do, so I'm going to get him right in. And, I talked to this guy a couple months ago. It was great. You guys know I love chopping it up with the scientists. I'm going to do a shameless slap here. BetterChem Consulting. And my guest tonight is Dr. Mark Scialdone. I think I said it right, huh?
Yeah. That's. I think it's in English it's Scialdone because the E is silent. Like Capone, Stallone, the E is silent, but in Italian it's Scialdone, Capone, Stallone. You see, like it sounds like a kind of macaroni or something.
Well, Mark, before we get into anything, would you mind sharing with us a 5-minute life story?
A 5-minute life story. Oh my gosh. Let's see. Well, that's covering 60 years in 5 minutes. So yeah, I was fascinated with chemistry as a kid. I had a chemistry set. I think a lot of kids who were sort of my age, so I grew up in the 60s and the 70s. Had a Gilbert chemistry set, right? And didn't pay attention to any of the directions. In fact, I think I got the chemistry set before I knew how to read. And I just, one day when my mom didn't know about it, I just took it out and I started mixing everything up and cooking away as a kid. And my mom came downstairs because she smelled I had lit a match, because when you light a match, you could smell it throughout the entire house. And when she did, I tilted the test tube and the stuff flared out and it singed my eyebrows. And it's the first time I'd ever smelt burnt hair. And my mom came downstairs and said, "You in chemistry, that's it. You're done." It's like, wait till your father gets home kind of thing. So, so let's just say I was predisposed to be a chemist from a young age. And then I did well in chemistry in high school. I had a really good high school chemistry teacher. I think a lot of chemists will tell you that, or anybody who gets into scientists, you could accredit a high school teacher for channeling all that adolescent energy into some productive mode. Right. So I studied chemistry in college and like college so much, I got a couple of degrees. I started doing undergraduate research, which was really kind of like an important step into the lab as an undergrad, which was kind of cool because this was in the early 80s. So there was instrumentation to be learned and, all kinds of glassware and beakers and stuff like that. So I got a degree. I got 2 degrees in chemistry from Michigan Tech, and then went and worked for a year at a pharmaceutical company in New Jersey, just long enough to know that I needed a PhD, sort of to be like an independent investigator in industry. So I went back and got my PhD degree only a year later. And it was nice to have that year of pharmaceutical experience in graduate school because I could kind of hit the ground running. And I worked for Carl Johnson at Wayne State. That was a great experience. We were one of the first groups to look at doing enzymatic transformations in organic solvents. So we were taking enzymes, which usually exist in aqueous environments, and putting them into organic solvents and doing all kinds of asymmetric acylation chemistry. It was really, really cool area to do graduate research in. And also did some transition metal chemistry that was really super cool too. And then I did a postdoc with a really famous professor out in Colorado in the early 90s. And his name was Al Myers, really interesting guy. And then from there, I went and took a job at DuPont Central Research in Wilmington, Delaware, at the experimental station along the banks of the Brandywine River, which is where the DuPont family first started making gunpowder in the early 1800s. And they started this huge chemical company called DuPont. And actually, the experimental station was really cool to be there because it was for someone like myself as a young industrial scientist in the mid 90s. This was sort of at the end of the golden era of industrial science that happened at places like Bell Labs, and DuPont Central Research was right up there as being like one of these meccas of just academic science that was happening, paid for by the spoils of industry, certainly, but there was just so much important fundamental science that was going on up and down the hallway of the place that I had just joined. It was almost as diverse as being a faculty member. There were people that were doing particle physics. There were people that were doing everything from transition metal chemistry to polymerization catalysis to new functional inks to bioactive molecules to, things that signal rhizosome, chemistry in the soil. I mean, just such a diverse area of chemistry. And when I first got there, it was just very open-ended. They just said, "Oh, there's a lab. Go do some science. Go publish in the literature." It was so cool. And so this was 1994, which is again is a bygone era. Right around Y2K, right around the year 2000, the mission of the company really changed from doing just blue sky research. I had 2 rounds of National Science Foundation funding, which brought postdocs to my lab. And as a young investigator with very talented postdocs, I was just having the time of my life. It was just a great place to be. But like I said, right around Y2K, the mission of the organization changed to be more applied research and less fundamental research. And ultimately, by the time I left, 10 or 12 years later, it had gone completely. Well, both Dow and DuPont merged. And when that happened, a lot of pieces kind of got splintered off. The company was so big, they had to break it into 3 different pieces.
Chemours, I believe Chemours was part of that.
Right. Chemours is the refrigerant and the fluoropolymer piece. I think Chemours also has some of the traditional large scale, like they used to make aniline down at Pontchartrain Works in Louisiana. And they had a lot of operations that were down along the Gulf Coast, centered around, where oil refineries are and whatnot. But I was involved in the Central Research Organization, which really was just sort of like a company funded, kind of sort of think tank research R&D proving ground to do new and exciting stuff. And it was exciting. When I first got there, up and down the hallway again, right up the hallway from me was a guy named Fred Tebbe. I don't know if you ever heard of Fred Tebbe, but he has a reagent named after him called the Tebbe reagent. Okay, I had actually used the Tebbe reagent in graduate school, and now here it is. Fred Tebbe is a couple labs down. and he liked the good margarita, if I remember correctly. He passed early on in my career, so I was really sad when that happened. But yeah, I just had a contact with a lot of great scientists, and I didn't realize it, Caleb. But like when I was working on one of the projects I had worked on, had to do with plant essential oil. We took a plant essential oil and made it into a insect repellent, and during that project, I had done my lab was responsible for all the chemistry, the analytical, and the making samples and making standards and running NMRs and making sure we knew what all the compounds in there were. So that was a super fun project. I didn't realize that when I was working on that project that was kind of like my training wheels for getting into cannabis like 10 years later. So that was probably more like a 10-minute life story.
No, that's fine. Sometimes they go half an hour. I don't care. And a lot of this other stuff was going to be more of your life story. I was super fascinated to hear that you work for DuPont. You know, and I know they have a lot of great scientists there. I sometimes question what they're doing there, but also I know they attract a lot of talent and they have the type of money to bring that talent in there. And I assume they have really nice labs as well. And fancy equipment and all of that stuff.
Oh, the best thing was the colleagues, the colleagues that I had and the mentors that I had. I learned a lot of chemistry from people who were kind of like a generation older than I was. And I was able to absorb a lot of, just practical knowledge about how to do chemistry and how to really understand, because that's always the thing that chemists are trying to figure out. Like, it's like U against delta G. It's like trying to figure out how chemistry works. And chemistry is a very unique science because we could draw chemical structures, on the whiteboard, and then we could actually go in the lab and actually make what we study. It's kind of cool. Like in biology, it's like, okay, here's what's alive. You could study what's alive. With geology, here's the rocks. You could study the rocks. But with chemistry, we get to actually make what we study. So I think I have to say, and I've said this a few times, that I think part of my attraction to that was hours of playing with Legos as a kid. Because and it wasn't like SpongeBob Legos or Star Wars Legos like they have now with directions, and it was just a box of just colored bricks, right? And endless hours of playing with them and putting them together in different combinations. I really do think that helped my mind develop an understanding of 3-dimension and an understanding of perspective, and I think it was really useful all those years playing with Legos. So have at it with the Legos, Mom. Your kids are going to turn into a scientist.
Apparently Lego didn't have their branding going on back then.
I think they did. Yeah. We call them Legos.
Well, they didn't have this. They didn't have the Star Wars shit and the fancy stuff. They just had boxes.
Oh, no. Right. It was just, they gave like there were certain bricks that you could plug wheels into if you wanted to make a car. You could make a car, but you could make, and they had kind of like flat green pieces that you could like turn into like a lawn, so you could make a house out of Lego bricks and surround it with green lawn, and that's as close as we got. But seriously, I think there was something about being able to take the Legos and stick them together in unique ways that is very similar to synthetic chemistry and the way molecules work and the way you build molecules and the way you construct compounds today are really there's a very kind of like building block kind of mentality and strategy that you use to like build one piece, build another piece, and then in a convergent way stitch those two pieces together.
And here I'm supposed to do shameless slaps every 10 or 15 minutes. I'm with Dr. Mark Scialdone, and I'm supposed to leave that out because we're in America, but that's That's how you said it on the phone. BetterChem Consulting, Mark. I got a couple big topics here that I think you kind of segued into for me. And it's, I think the first one on the table might be the synthetic cannabinoids. You said you're building sort of like Lego chemistry. And it seems like there's a lot of that going on. And I've spoken with a number of labs around the country. And I see that the state governments around the country are trying to crack down on these synthetic cannabinoids, the Delta 8 and the hemp derived stuff. So maybe that would be a good place for us to start digging into right here, man.
Yeah, I mean, I think it was, we published a paper, myself along with two physicians, Jordan Tischler and Michael Getze, on the unanticipated outcomes of the Farm Bill, which was, a great leap forward, to remove, hemp from the Controlled Dangerous Substance Act. But, it fell short of contemplating what farmers were going to need to do to create a value chain that was going to be sustainable. Let's face it, they didn't give farmers a out really to think about, what does the CBD, forget about conversion to THC for a second, what does the CBD market look like? There's a law called the FD&C Act, which prohibits the use of active ingredients of FDA approved drugs in food, feed, or cosmetics. So the nascent CBD industry is sort of hamstrung by the fact that the FDA has not properly regulated the plant after harvest. See, that's one of the things that people get hung up, Caleb, is that Farm Bill is the sort of regulatory, government's regulatory auspices over the plant that ends at harvest. So that plant may have tested as, low THC or low THCA or however you want to look at that. That's a whole nother thing to open up. But when you call the plant hemp at that point, but then drop the ball on regulating how that feedstock is then turned into products intended for human and animal consumption, it really is in the bailiwick of the FDA now to regulate what happens to hemp after it's harvested. And because they haven't done that, they've basically left a lot of, real estate open to be exploited. And that's exactly what's happened. And this synthetic cannabinoid thing kind of proves what we all know. In fact, I don't know if you saw, there was a recent paper that was funded by NIDA, go figure, right? That basically showed that, states that do not have cannabis or access to medical cannabis or access to recreational or adult use cannabis, if you want to call it that, have a higher propensity of ingesting Delta 8 products. They needed a federal study to basically figure that out. I mean, I think we could have guessed that from day one. But it's good to actually see that there's statistical data now to back this up, to say, look, if you want to regulate this plant and you want to keep people from having access to cannabis, they're going to find these recreational synthetics, man. And that's because humans want cannabis. We've co-evolved with this plant for a millennia. It got us drawn on the walls of the cave, man. I mean, it's like that thing that we know that the Schedule 1 listing of cannabis is completely a spoof, because the FDA has approved medicines whose active ingredients are derived from the plant. So how could you say there's no medical use to this plant?
Talking about
the FDA is just looking at the clinical data, right? And the clinical data shows that this drug over placebo is effective. So the drugs were basically approved. Well, if they were approved, isn't that medical application? How could the plant from which they're derived still be listed as something that has no medical application? There's that, but there's also the well-known government patent on the neuroprotective properties of cannabinoids, right? So the USPTO also doesn't pay attention. This is the US Patent and Trade Organization, doesn't pay attention to drug policy and doesn't care whether it's Schedule 1 or not. They showed data in that patent to say, here are the neuroprotective properties of cannabinoids. Well, let's see. They're hydrophobic molecules. They're phenols. Phenols are typically antioxidant. They have antioxidant type activities. So yes, does the antioxidant properties of these molecules end up protecting brain cells in the case of a hemorrhage, or in the case where there's some type of reactive oxygen species which is causing free radicals? The answer is overwhelmingly yes. And according to the USPTO, you couldn't have predicted that result until that US government lab with that smuggled THC figured that out. So when they figured all that out and they filed a patent on it, again, I'll go back to the question of how could it be listed as Schedule 1 with no known medical use when the USPTO, right, another wing of the government, has said, no, there is medical use. There's neuroprotective properties to these things. And people are now exploiting these things. And here's one more, Caleb. The government had actually licensed this patent to a company called Canalife in Doylestown, Pennsylvania. So I don't think they exist anymore. I think they've I don't know, had to go through refunding and rebrand. I don't think Canalife exists anymore. But at one point, the U.S. government was collecting licensing revenue on their cannabinoid patent while they're locking other people up and calling it a Schedule 1 substance. So what was your question again?
I'm going to go to the next one. I think you nailed that one. I got a comment.
I think you're talking more about, so my opinion is that if the Farm Bill sort of created this plant-derived material called CBD. CBD is non-psychoactive, although CBD does act as a negative allosteric modulator at CB1. And CB1 does have a variety of different activities. CBD, not CB1, has a variety of activities in the body. So there's like a lot of different things that CBD does that THC doesn't do. But I don't think that they contemplated the chemical conversion, which I think is the kind of the question you were asking about, which is these recreational synthetics like Delta 8. Well, Delta 8 is the THC isomer that's not made by the plant. I mean, that's something that you often hear that's misinformation, is that, oh, there's small amount of Delta 8 in the plant. No, there isn't. There's no Delta 8 made by the plant. The plant only makes Delta 9 configured cannabinoids, and any Delta 8 cannabinoid or any Delta 8 THC, I believe, is just an artifact of the HPLC measurement that's being made, because it's very easy to get isomerization of Delta 9, a natural configuration of THC, to Delta 8, because it's thermodynamically downhill, which means once it goes downhill, it doesn't go back to Delta 9. So I think the minuscule amount of Delta 8 that may or may not exist is a human artifact that doesn't happen until there's human intervention of the plant. There is no Delta 8 inside a plant. And I've looked at thousands of COAs, and I've looked for where is Delta 8 occurring in plant material, and I just have not found it. I've also asked several other researchers, and they haven't found it. So I believe Delta 8 in and of itself is something that doesn't get made until humans intervene in a plant. Think of it, Caleb, like it's a degradation product like CBN. So CBN, the plant doesn't make CBN, but if given the opportunity, THC, little sunlight, little air will oxidize up to CBN. If given the opportunity, delta 9 THC can and will isomerize over to delta 8. But that doesn't mean that it's made in a plant. That means it's made on some aging process, or typically if delta 9 sees acid, the acid is enough to basically move the double bond from delta 9 configured over to delta 8. So just even filtration through like a medium like clay, like some people use clay to decolorize their distillate. The first time I saw delta 8, the first time delta 8 sort of reared its ugly head in cannabis circles is when the folks in California, maybe about 10 or 15 years ago, were making the clear. In fact, the clear got their name because what they were using were decolorizing clays, adding those to distillates, and then doing a short path distillation. And what they were seeing was a very clear fraction. And they're like, wow, man, this is clear THC. Well, they didn't realize at the time because they didn't have sophisticated analytics. But now we know that was all delta 8. So the clear in California, that brand name was based on taking old, not so good looking distillate and remediating that by adding clay to it and distilling.
Don't jump to the remediation yet. I want to slap I want to slap a couple comments if I could here.
Sure.
Miggy 420, have you guys talked about testing? Ask him ASTM's preferred method of testing for THC percentages. Also, ask him, I thought it was all D star. I don't know what that means, Miggy. I thought it was all D asterisk until it was D carb.
Maybe D9.
He said also, there it is. I thought it was all D8 till it was D carb. Okay, so yeah, go ahead.
No, so the plant only makes D9. Plant makes D9 THCA, right? And then if THCA, so the A stands for the acid, right? And so THCA is a white crystalline powder. It's 87.7% THC. So when you heat that THCA up, it loses the carboxylic acid in the very well-known reaction called the decarboxylation reaction. And that now makes THC. And if you can compare the CB1 binding constant, CB1 is what THC is a partial agonist of. And when you look at the numbers between THC and THCA, there's no question about it. Converting it to THC activates it for binding to that receptor. There's also the notion that THCA, because it's a little bit more polar, has some issues in getting through the blood-brain barrier. That's been debated in the cannabinoid research journals. But delta 8 is only made after THCA decarboxylates, makes a little bit of delta 9 THC, and then that undergoes some type of thermodynamic stress. Now, thermodynamic stress could just be heat. Heat, think about it. You have two molecules. One is downhill in energy and one's uphill. Sometimes acid will take you downhill, sometimes a little bit of heat, sometimes acid and heat. And sometimes, it's funny, there's this guy who's a professor at UConn. He's a really interesting guy who claims that just heat alone can catalyze the conversion of CBD into THC. And what I told him was, well, you have to remember that even just glass itself is somewhat acidic. So heating up CBD and melting it and then seeing some of that convert to THC, well, maybe the glassware itself is the acid catalyst, because a catalyst is something that you only need a little amount to catalyze a reaction, go over and over and over and over and over.
And I talked to a guy named Josh Swider out at Infinite Chemical Analysis Lab.
I listened to that. That was a good one.
Yeah, and he told me that in the process of some of these conversions, there are these other byproducts that are popping up that And I believe he said, I'm paraphrasing, but I believe he said some of them, they don't even know how to identify. They don't know what these are.
That's not entirely true. So this is great discussion to have, Caleb. So let's see. This would be almost 2 years ago. The American Chemical Society's cannabinoid chemistry subdivision, of which I'm a founding member of, we had a YouTube discussion about Delta 8 chemistry. So I encourage anybody who's interested to go look up that YouTube discussion. And what I would point to is I describe on the surface some of the chemistry that has been known since the mid 70s, which is that when you take CBD, CBD, I'm going to use my hands here, like a good Italian, right? Talk with my hands.
I was going to say.
CBD sort of has two portions to it, right? It has the phenolic portion, right, with the two phenol groups. Those are the oxygens that are on the benzene ring. And then it's got the terpenal portion, which kind of looks like limonene. If you look at limonene, it's like, yeah, it looks like a limonene molecule. The two Legos that are stuck together, in this case, limonene is one of the Legos and olivitol is the other Lego. Well, here's the thing. When you convert CBD into THC, first of all, what you're doing when you're looking at the molecular structure, what you'll see is that CBD has got 2 rings where THC has got 3 rings. That's the thing that looks like chicken wire, the hexagonal chicken wire kind of thing, right?
Thank you for breaking this down. Please talk to us please talk to us in those layman terms, because that really helps me understand this as well. But yeah, sorry to cut you off.
When everyone knows these are the structures of our beloved cannabinoids, and you'll see me up on LinkedIn just destroying people whenever they get these structures wrong. It bothers me. It really turns my screws that they want to talk about their CBD product and then they put the wrong structure for CBD up there. And I'm like, hey, man, your CBD's got an extra methyl group, or that's in the wrong place. And people are like, dude, you don't need to correct all. It's like, no, wait a second. Chemical structure needs to be correct. It's language unto itself. And these are our beloved cannabinoid molecules. And I don't like when people don't get the structures right. So many people are learning everything we say. We got to make sure we get as much of this information correct. And it might be correcting a boiling point, or it might be correcting a chemical structure. But I think it's really important to make sure you're getting these things right. So when you close that third ring to make THC, you're using an acid to catalyze that reaction. And it's a known reaction. In fact, it uses an intermediate called a carbonium ion, which is classic organic chemistry. This is what you learn when you're a sophomore in college and you're taking organic chemistry. After you've taken general chem, then you get thrown into organic chemistry. But what you're learning is basically that you could convert one molecule into another through these intermediates called carbonium ions. And so what happens is the proton from the acid protonates the ring. You basically make a carbonium ion and it closes the ring to make THC. The problem is that those two pieces can also, under the same conditions, can come apart and recombine, come apart and recombine. And when they do that, there's a stereochemical consequence to that, because if you know the stereochemical configuration is when you're looking at the absolute configuration of the molecule and you're not looking at its mirror image, which is non-superimposable, you're actually looking just at that molecule. THC is in what's called the trans configuration. Well, when it recombines, when it comes apart and recombines, it doesn't necessarily come back in the trans configuration. It could come back from either the top or the bottom, which is going to either give trans or cis. The other thing, and this is the thing that we pointed out in our paper, in the Getzy-Tischler paper, which was that when they found olivitol, there was a study of some vape pens that were studied at the University of Rochester. This was at the end, I believe, of 2021. And what they found, what was alarming to me, is that they found olivitol. Now, remember the two pieces of the molecule, you have the limonene portion and you have the olivitol portion. Well, I think what that says is in that reaction, you're disassociating it, and then something's happening to the limonene piece to leave the olivitol piece in there, because olivitol should not be in there. And the fact that they found it, I think, in 18 of like 29 samples that they looked at, was pretty alarming to me. What that says is that the acid catalyst that they're using to convert that reaction is just too strong, and it's tearing apart those molecules, and they're finding other thermodynamic paths to wander down, which basically results in having these gross reaction mixtures that then people are putting into vape pens because they need to make money.
Shameless slap. I'm here with Mark Scialdone, BetterChem Consulting. Try not to explode my head too much, Mark. Chemistry is so far above me, and this is why I talk to guys like you. And the testing certainly has been a big piece. I don't know if you want to talk about that, but since someone dropped a comment, I've talked to a bunch of labs about the inflation, the THC inflation,
Right.
Some weird pesticide testing, and pesticides is another issue I was hoping we could touch on.
Yeah, sure. So, I mean, a lot of these I will, just because it's not an individual and it's not someone that's going to write me some negative letter, I'm just going to blame on prohibition, which isn't a person at all, right? It's just a thing that exists, right? So think about the psyche of the dispensary purchase. When the customer is in there and when they're looking to buy something and they're thinking, geez, there's a nice aquarium there, there's a nice couch there, there's a reason why I'm paying $60, $70 for a small little jar of weed here, and I need the most THC bang for the buck. And so what sells? I think now there's a little conventional knowledge that THC percentage isn't as important. And I'll point out the important work of the group at Abstracts. Ian Oswald would be a great guest for you to get on, Caleb, talk about what they're doing. Their group is basically the group that discovered the volatile sulfur components and the non-terpenoid components and these sulfur things that really give weed its gas. But the other paper, which was just about the most fascinating paper that I've read in the last several years, would be the Jeremy Plum Nose paper from the end of last year, which basically points out the human interaction with the plant, which goes just way beyond a terpene profile, way beyond a single terpene or a molecule, or even beyond the strain. The way that people interact with the plant, and certainly the way that different growing techniques, whether you're in rockwool or you're doing regenerative farming, what type of product preparation are you smoking? Flour? Are you doing dry sift? Is it rosin? Is it BHO? There's so many different kind of ways that people like to experience the plant, so you can't really say that one way is wrong or one way is bad. But I think those of us who know kind of heady cannabis oil, once we started trying live resin, and I'll shout out Kind Bill, the inventor of live resin. Kind cool. Bill's a close friend, and great guy to talk with. But the notion that you're capturing the essence of the plant, I think, plays into the medical aspects of what's called the entourage effect, right? Which is that the way humans experience this plant is not just based on THC percentage alone, but what's based on THC percentage, to go back to your question around testing and lab shopping, is all that is, wholesale prices and, how much manufacturers and growers are paying and buying, product for. Because let's face it, when you buy that jar of weed at the dispensary, It's gone through a couple hands. So the dispensary owners need to make money. The distributors need to make money. Certainly the grower needs to make money. Now throw, processing in there. So if you're buying rosin, the rosin guy needs to make money. So there's like testing, unfortunately, is the only way. Like if you were to just look at two nugs, like I was saying to someone the other day, we used to grow this weed. We used to call it paint can, and it looked beautiful, man. The colas on it were as big as a football. These things were just beautiful, but you'd smoke 10 joints of that and you would not get high at all. Well, we didn't realize it was probably just a CBD variety, right? It just didn't have THC in it, right? Like you'd smoke it all day and you wouldn't get high. So we didn't know, but now with testing, you'd be able to know, oh yeah, that's a CBD variety or a CBG variety. So is testing important? Absolutely. I need testing when I'm making products to be able to determine whether or not the dose in the final product is going to be right. Like when you buy like a 100 milligram, I don't know, whatever, candy bar or 10 milligram drink or something like that. How do you know how many milligrams went in there if you haven't tested the flour? You test the flour. Then if you make some type of extract or a preparation or a crude, you want to test the crude, right? So you know how many milligrams are in a given amount of that material. And then you use that number in your recipe to make the cookie or the brownie or whatever. You know what I'm saying? So testing, if you don't have testing, you're just it's like flying an airplane with no instruments. Could you hit the runway? Yeah, you probably hit it, but you might overshoot the runway a little
bit. Damn. Okay.
I mean, I don't know. I don't want to throw testing under. Often testing will get thrown under the bus. And I saw that you interviewed Holly and Callie, and shout out to them. Those guys are doing a great job over there. Testing are doing the best they possibly can. They're hamstrung a little bit by the freaking regulations too, right? And think of it this way: like here in Vermont, right? You drive the samples to the lab, don't you? So you can basically pick,
or they do have a couple drop-off points at different dispensaries where you can drop it off. I think Forbin's is doing that. I think there's
I guess I'm not so much concerned. I'm not so much concerned about the transportation of the samples themselves, but like in Maryland. So I consulted down in Maryland, and what I can tell you down there is you have to make an appointment with the state cannabis commission and have somebody come to your grow to witness the guy from the testing lab taking random samples out of your production lots. Yeah. That's how sampling should happen, right? Because now the testing lab is involved, but now again, it complicates testing because now as part of your testing lab, you have to have a fleet of employees going all over the state to every grow and every production facility to make sure that you're getting a fair sampling of what that producer is producing. But I don't know how you would get around that. I mean, if you're just choosing the material because the farmer brought it in, the farmer is going to bring the most potent material he possibly can. Again, let's blame prohibition on that because he or she needs to get the most value based on what investment they made to make that plant material, right? Is that right? I mean,
I in my opinion, yes.
so then even if you get like numbers like in the high 20s or something like that, but what that farmer actually sells is in the low 20s or upper teens, and that they cherry pick the result. I mean, who gets screwed there?
Well, I still think fucking THC percentage is overrated. So I'm not sure who gets screwed there because I've smoked some 15s that just rock me. And I've smoked some 30s that are
That's right. Okay. Well, in general, cannabinoid potency goes up with trichome density. And trichome density, the more trichomes you have, the more THC you have, the more cannabinoids you have, the more proper that weed was grown. You know, I don't know how you solve this problem, because the dispensaries and the manufacturers and the producers need some kind of metric. And well, and I can tell you this, Caleb, just so you know, like when you test a plant material for THC, that means something to a processor. Now, if I'm going to go extract that material, whether I do like an ethanol or CO2 extraction or whatever, however I extract that material, that THC percentage basically can forecast how much THC I should get if my extraction is efficient. Now, that's a big if too, because I think a lot of people may not actually be doing it. The most efficient extraction, maybe leaving some plant material behind. Or like if you're doing a water hash, for example, some terpenes are water soluble. So how many terpenes from your overall terpene expression in a plant do you lose in the hash water? I don't know. When you press bubble hash into rosin, there's hang up in the bag. I mean, does everyone know? I mean, there could be, again, probably ways that you can extract that are just more efficient. So the THC number does make a difference in that when you're looking to make a refined THC product, that the mass balance along the way makes sense. Does that, I kind of tried to break that down. So, like if you extract something that's got 20% versus something that has 10%, you should get twice as much oil from that, right? Just because it's twice potent, right? Right. So if you're getting twice as much oil, well, that's, 1,000 vape pens as opposed to 500 vape pens, right? So the point is that I think, unfortunately, again, tied back to prohibition, these farmers who are just trying to make as much margin as they possibly can, processors, and everybody along the value chain between the customer and the dispensary and the grower, there needs to be enough money to be able to pay everybody to be able to make a sustainable business model.
And maybe if they dialed those taxes down a little bit, that would help.
That would what that would help with, Caleb, is basically keeping people from going to the black market, because the black market pays no tax whatsoever at all, or legacy market, I guess you'd call it.
Yeah,
legacy market doesn't have to pay a tax. So, $40 quarter, right? There's no tax on top of that. So what's the incentive if someone's going to have to pay more? Well, now they're going to get something with a test result on it, right? Because in order to buy that at the dispensary, they had to have the test results. So, I think test results are important, because I think what we're doing is we're educating a population on what's important in the cannabis that they like. Right. So when they see train wreck, they could say, terpinolene. Terpinolene is that terpene. That's the one. Right. Or maybe they could, again, feel that they can be bold to maybe look at a different, let's go look at Jack's Cleaner. Jack's Cleaner is high in terpene, so they could maybe branch out from like herb strains or varieties that they like based on data and analytics. That, I think, is the cool end of testing, right? Discovering more about like what's in cannabis that makes people love it so much.
Yeah, and I think that's cool, but I don't think you should like have to do some of that stuff. And you're right, like the difference between 20% and 10%, for sure, if you're washing, that's going to be huge. But the difference between a 12% joint and an 18% joint, some of those you might not even notice a difference in. And I've also heard, can I ask you this? Some people have also been suggesting that there's other factors besides the terpenes, the flavonoids and shit like that. I'm not familiar with that at all, but I'd be curious if
Flavonoids are in there. They're not psychoactive. They certainly have nutritional qualities to them. The flavonoids, backing up to a more greater class of flavonoids, are things like the anthocyanins and the pigment. Like, I don't know if you've ever seen like someone who's washing like Granddaddy Perps. You see that water. That water is like magenta in color. It's like,
so that's the purple. The purple is the anthocyanins, right? I've read about
that's
this.
correct.
I feel like
That's correct because they're water soluble. So they're not typically found in well, and I should say like so anthocyanins and a lot of those complex pigments, they have, again, I'll use my hands. They have two components to the molecule. There's kind of like a glycoside portion, which is a sugar that makes it water soluble, and there's what's called an aglycone. Typically, what you find in the in cannabis extracts or distillates and oils are the aglycones, because the carbohydrate makes this thing water soluble. So they don't typically extract. Well, I think they can extract into ethanol. So if you get like a dark ethanol extract, they could be in there, but they're not thermally stable. So I think when you heat them up to distill them, I think all you're getting is the aglycone. And to be honest, the only thing I really know about flavonoids, I mean, they're great antioxidants. They also impart a lot of color. So I think the golden color that you often associate with distillate, with like CBD is usually more of like an amber color, and THC can almost be almost like a reddish color. Some of that color, I do believe, is due to trace amounts of the flavonoids, because flavonoids are highly colored. They have what's called a high extinction coefficient, which just means a little bit of molecule goes a long way to color a lot of stuff.
Okay. Here, I'm going to do another shameless lab here. BetterChem Consulting, Dr. Mark Scialdone. And you touched on this a little earlier, and I think this is going to be a fun point of discussion here, is about the different types of extraction. It sounds like that's something you've worked on a lot. And I know we talked about this on the phone, the different types of gases that are used for extractions. And I'd love to get into this.
Well, it's kind of like, wineries don't sell grapes, do they? They sell wine, right? So to be biblical, it's the fruit of the vine and the work of human hand, right, that creates these extracts. And I mean, there's no better expression of the plant itself than a full spectrum extract that's properly made. And I always say this, Caleb, I say if it's golden on the plant, it should be golden in a jar. And if you have some black, dark extract, to a chemist, that usually means some type of oxidative degradation, or some kind of degradations happen, because it ain't black when it's on the plant. Now you've concentrated this extract, and man, that RSO or whatever that stuff looks like is super dark. So I like, again, big fan of live resin. Live resin, for those of you who don't know, is just freshly frozen plant right at the time of harvest. So they're almost trimmed while they're still alive. And then as soon as you whack them down, you get them into the deep freeze. So what you're doing is you're taking a snapshot of the terpene profile that day at harvest, and you're able to express that in a closed loop hydrocarbon extract that unfortunately we can't make here in Vermont. Oh, wait a second. You can if you're one company in particular, right? So, so that's something that Vermont needs to fix. They need to basically level the playing field in terms of having closed loop hydrocarbon extraction available to all tier 3 operators, not just one. And I believe that, again, there's the misconception that butane and closed loop hydrocarbon extraction is dangerous.
That was my next question, and yeah, please explain that, because I know we had a great conversation about this on the phone, and it's this again is over my head.
So what's
But
dangerous is when you have a propane tank hooked up to an igniter called a gas grill, right? You know, I mean, everyone's got one of those, but somehow if you want to use a closed loop butane system to extract plant material, which has been done safely at hundreds of facilities across the country, I've consulted with almost 24 different facilities in as many states to basically put in those types of facilities. And this is how you can make a good live resin product. I believe live resin, I really am comfortable to say this, is the pinnacle product that you can get from cannabis plant. I do believe that is the product and that is the extract that presents the genetic makeup of the plant, all the work that the grower has gone in to cultivate that plant. I
yeah,
think there's no better extract product out there than live resin to represent what that plant is. And really, I mean, you can't make this with well, you need a cold extraction because you can't extract fats, waxes, or lipids. Taking it through a winterization process is just terrible to do because you end up losing terpenes that way. And I think people have come up with innovative ways of making sort of like a live rosin product that's almost as good as live resin. I'll challenge some of my rosin maker friends, but I would say that again, when it comes to the scalability, which is really important because these businesses have to operate in terms of profitability. When it comes to the scalability, overall reproducibility, worker safety, and on many different levels, closed loop hydrocarbon is really the preferred extraction by top-notch connoisseurs, and the market here in Vermont, Caleb, will eventually get there. They're just not there yet. I think there's certainly a market for solventless products, certainly a market for rosin. I just think that rosin is just going to have a tough time competing with the scalability of closed loop hydrocarbon at production scale.
yeah. I just thought it was a little. I thought. Well, sorry. Finish up, please.
No, I was going to say that's just my own opinion.
And I was curious why it seemed like they made some distinction between butane and propane, which I didn't really understand. Is there a difference between using different gases to do extractions? I was curious if you could tell us about that because that's fucking way over.
Well, so butane is a C3, and I'm sorry, butane C4, and propane's a C3, so it's one less carbon. Because it's one less carbon, it's much more volatile. It has a higher volume of expansion than butane. So yeah, propane. You use propane. Ideally, you're using something like a 70-30 mix, 70% butane and 30% propane. And the reason why you do that, Caleb, is that the amount of propane that's in your recovery, what helps you in the speed of your recovery. So remember what you're doing is you're packing an extractor with now frozen cannabis. So think about just regular cannabis. Now freeze it, right? Fresh frozen cannabis. And now you're forcing this liquid through there. So there's a lot of back pressure behind it, but there's still an incentive for the gas to get through because the gas wants to expand. It wants to get out of a smaller confined volume and get to a bigger volume. And in the recovery, if in that 70-30 mix, because the propane is more volatile, you get a better recovery. You also, I mean, PHO, which is as opposed to BHO, just running straight propane, gives a much lighter colored fractions. I don't think the yield is as good because I don't think the solubility is as good, but it has a lot to do with the quality of the plant material that you're extracting. If there is any fugitive moisture, moisture, you're up against the time, because what you're trying to do is extract this material with the coldest solvent you can while it's frozen solid. I mean, that's kind of a challenge to do if you think about it, because as soon as you take it out of the freezer, it's going to start heating up and start warming up. So
you called it a fugitive, like Harrison Ford or something.
Yeah, well, to a chemist, something that's fugitive is something that's it's escaping, and so like the gas is sort of escaping from there, and I said the moisture could be fugitive in there too as well. So there could be moisture escaping into the oil, which is often the reason why people will run a column of molecular sieves, because when you take your material and run it through the molecular sieves, it'll dry out any moisture that the gas solvent may have picked up. But the important thing about this, Caleb, and I can't emphasize this, is that when you do the extraction under those conditions, you're basically robbing the trichome of what humans want, right? Which is the cannabinoid profile in its complete and full expression, along with the terpenes and the flavor. So, I mean, that's what you're getting out in the extract. And really, you can't do that with other solvents. And it's difficult to do in a solventless way, although you can do it. The question is whether or not it's scalable at commercial production scale.
Huh. Okay. Good. I'm glad I got you on. I got to do another shameless slap here. And here's this other guy. Oh, he came back with the comments. Miggy 420. Great question on the gases. Yeah, that's why I bring smart people on, Miggy. Mark Scialdone, BetterChem Consulting. And a big topic I really want to ask you about is this idea of, and this is a new idea to me that I only learned about last year, is the remediation. The different types of, I see they're using ozone, they're using X-rays, they're using RF, and things like that. And I'd love to hear your thoughts on the remediation going on in the cannabis industry.
Yeah, so I think remediation means a lot of different things to a lot of different people. I think that's what we've figured out just by having our discussion with each other, right, Caleb, is that people are using the word remediation. It's like that one girl was on here saying that, oh, you could just remediate the material by extracting it. What? Are you kidding me? That doesn't remediate anything. So I think when you're talking about remediation, there's one thing of remediation that I think is really important probably to this audience, and that is when you get something that fails for whatever reason. So whether it's flower material or an extract that fails for either a solvent or fails for pesticides or fails for something, the remediation of that material is to say, okay, this material is now contaminated. In some cases, it's tracked on the state seed to sale tracking systems, so the state knows that you just made a bunch of stuff that's, got lead contamination or some kind of, aspergillus contamination, something that basically is keeping it from being sold. So how do you remediate stuff? Okay. Well, again, I'm not a big fan of companies that are selling picks and shovels that enable people to make moldy and fouled weed, that they could just run under a set of lights or an ozone generator, say, oh, we've taken care of our mold now, so it's okay to grow PM. It's okay for our stuff to fail on PM because part of our protocol is we send it through this tunnel where magically the PM goes away. Well, the PM doesn't magically go away. And all I can tell you is that, ozone has typically been used in disinfecting applications because ozone is a very highly reactive molecule that immediately reacts with most organic molecules, including cannabinoids and including terpenes, right? And so anything with a double bond, any unsaturation, a degree of unsaturation could just be a double bond, like in an oleic acid molecule, there's just one double bond there. Or it could be like in the cannabinoids where in CBD, there's two double bonds. In THC, there's one double bond. So ozone reacts with double bonds instantly. Instantly. There's no like, oh, I might react with that double bond. It's going to find that double bond and instantly go after that double bond and immediately react in an irreversible way to make something called a primary and then a secondary ozonide, which
I
ultimately,
believe it. Can I cut you off? I believe the word you said was indiscriminately, perhaps.
indiscriminately, yeah. So it's kind of like, well, I don't know. I think of it almost like the way I think of like hydroxyl radical and helper T cells in the body. So helper T cells have figured out how to generate a hydroxyl radical. Hydroxyl radicals, OH dot. Man, that is like a very reactive chemical species that'll instantly start reacting with any hydrogen molecule it finds. So my question is well, how do you generate hydroxyl radical inside a cell without the radical itself destroying the cell that's generating it? So somehow helper T cells figured out how to hijack a calcium atom, and the hydroxyl radical kind of holds on to calcium. And when it's like fire all weapons, the calcium lets the hydroxyl radical goes and it destroys that whatever it's trying to destroy. So
yeah, Mark, you're trying to destroy my brain on this interview right now. God damn.
So like ozone, like the way we would test. So I used ozone a lot in my days in the laboratory. In fact, we had an ozone generator in my laboratory that we actually adapted from an ozonator that's used to generate ozones for pools and spas. So we took a pool and spa ozone generator, and my machine people adapted it so we could use it to generate experimental amounts of ozone, so we could do ozone chemistry. And so, make a long story short, ozone reacts with double bonds. So things like terpenes. So the reason why ozone is used as an odor mitigation method in cannabis grows, they have these things that basically circulate the air through an ozone generator. And so the way you generate ozone is you make a little mini bolt of lightning. So when you're seeing lightning outside, in fact, when you smell a lightning storm come on, that's often the smell of ozone. So you could actually smell ozone after lightning has gone through humid air, because when you see that bolt of lightning, what's happening at the molecular level is you're converting O2 into O3 in like middle of the sun kind of chemistry, So it's like, okay. So anyway, this little mini bolt of lightning in this ozone generator basically takes the odor from your cannabis grow, and you're using a fan, and so you're pushing it through there, and so that lightning basically makes ozone. The ozone basically reacts with all the unsaturated molecules. It also reacts with sulfur-containing molecules. So think about it. Things like sulfides, which are super stinky, those will react with ozone and make things like sulfate or sulfonates, things that are not as stinky, that don't have the same rotten egg sort of profile that some sulfur compounds do. So ozone has been used in cannabis quite significantly as an odor mitigation method. So it baffles my mind that this company is actually using ozone generating machines to say we can remediate your moldy cannabis that way. Ooh, boy, it gives me the willies when I think about that. And what I also know, just because I read the paper, is that, does radiation kill bugs? So if you have some type of fouled cannabis and you treat it with radiation, the radiation kills the fouled cannabis, but the carcass of the microbes are still there on your cannabis, so you're still smoking it. So it's like, do we really want to encourage growers to grow moldy products by providing them picks and shovel tools to, remediate their moldy cannabis? I don't think so.
And I think that's one of the biggest arguments that I've heard is that, maybe it will kill if you have, say, I pulled out a giant fucking moldy nug here, and maybe it was remediated, but I've heard them described as skeletons of the mold spores will stay on there. And I'm going to talk with my hands too. I could be Italian. But that's one of the foremost arguments that I've heard is that, even if you kill all the mold, which is questionable, and I've heard that sometimes all the mold does not get killed by some of these techniques and will start regrowing.
Oh no. That's again a little bit of a misconception. So if you do an alcohol extraction, you killed all the mold. There's no mold in there.
Oh, I was talking just about flower there. So yeah. Go ahead.
But what you haven't killed is if the mold, while it lived on the cannabis, and it's not necessarily mold, it's bacteria and all other kinds of shit that can live on cannabis. While they live on cannabis and they're eating, first of all, they're eating trichomes and they're eating terpenes and they're basically eating stuff that's going to lower your overall test results, right? So that sucks because if you have mold infestation in PM, usually your potencies are lowered. But the thing you have to, and I guess this is, again, I don't know much about this, but what I can tell you is that some certain strains of molds and certain fungi can create what are called mycotoxins. Now, we test for mycotoxins here in Vermont, and I think they test in a number of different states, but I'm not sure that the mycotoxins that they're testing for have ever been observed on cannabis. They're like aflatoxin, which is basically peanut toxin. So, here's some funny information for you, Caleb. So they always say, oh yeah, no one's ever died of cannabis. Well, people have died from eating peanuts because they eat peanuts. They have the peanut allergy. There's aflatoxin on there. Aflatoxin is highly deadly to people who have peanut allergies. And now here it goes. Peanuts are more dangerous than cannabis. Okay. Because people are dying from, but that doesn't mean we should be testing cannabis for aflatoxin, right? Aflatoxin is made by bugs who get on peanuts and start destroying peanuts, but it's a knee-jerk reaction is what I'm saying. The other thing is doing pesticide testing of flower makes sense, right? Because you could apply pesticides to flower material. But if the flower material was clean of pesticides, why should you have to test the distillate? Shouldn't distillate that's made from clean flower material get a pass on having to do this expensive pesticide screen? We already know that the flower material had no pesticides in it. Now all of a sudden the distillate's going to have pesticides. Well, that would mean that the pesticides would have to co-distill. Let me tell you something. None of those pesticides are built to fall apart if they're heated or you shine the light on them. In fact, this is the biggest problem with pesticides in general, is that there are no approved pesticides for use on cannabis. Zero. In spite of what regulatory authorities like the CCB and other state authorities will do, until the onus is on the active ingredient producer to bring to the Environmental Protection Agency that regulates pesticide registrations, here's the use of this pesticide on this crop, i.e. cannabis, for this intended use, i.e. smoking and concentrates and edibles and all that. Until that's done, and no company has done that, because you have to show a safety study, an environmental fate study, and all of that work that you need to get a pesticide registration. Until somebody does that for use on cannabis, none of these things can be used on cannabis. So there shouldn't be any pesticides applied to cannabis across the board. Zero. Until we know what their impact is going to be on humans who consume cannabis that those products are being used on. They go with generally what are called biopesticides, which are often just, bio-derived materials that are less harmful. You don't find synthetic chemicals like Eagle 20 and all that in there. But now, again, growers are faced with a real dilemma here when they get infestation or they get, potential loss of a, multi $100,000, $1 million crop. Do they spray and hope that that pesticide goes away by the time they test? Or, this is all, again, an artifact of prohibition, I do believe. But until we have companies that own registrations for those active ingredients on crop protection products that are specifically applied to cannabis, there shouldn't be any pesticides used at all. Zero.
And a phrase that great point. A phrase that I heard used recently was people are just spraying outside the list. Some states, I think California has like 60 something, and, and people just find out the ones that they're not testing for and then use those, which is also fucked up in my opinion, man. But I also feel
properly grown cannabis grown in a proper way does not need synthetic pesticides, period. There are ways to use integrated pest management and regenerative growing techniques that is, something that maybe the cannabis industry can teach conventional farmers. But I'll go back to just the human safety aspect of it. If you're spraying whatever, you have to assume that whatever you're spraying to that plant is not going to somehow deleteriously impact the humans who are going to consume that plant. And, there's no safeguard. There's no what do they call those? There's no guardrails. It's just an open thing,
Yeah, and from what I've met up here of the growers, most of them are pretty straight up trustworthy guys, but you got to assume that, and I know because I've met some of these other guys that, that are not good growers, and they're using these chemicals to sort of cover up for their inability to solve for root cause, in my opinion.
Well, and most likely they can probably dump it into the legacy market where there is no fucking testing, and as long as it smells good, okay, yeah, you could sell that cannabis. So again, this sort of maybe heightens the need for testing because of that kind of shadiness. But what are you going to do? I mean, if you're faced with losing your entire farm, and you're going to either be either completely financially ruined, or you're going to what they call pray and spray, probably spray and then pray, right? get the order right. Spray and then pray that it doesn't come up, or somehow it degrades. What to be fair, again, what makes a crop protection chemical today, like an insecticide, fungicide, or an herbicide today, is not a chemical that kills bugs. There's lots of chemicals that kill bugs. It's a chemical that does so safely when applied, and then degrades by the time those lettuce or beans or apples make it to Whole Foods, right? I mean, so the point is that you're going to spray it. It's going to have that sort of prophylactic effect to protect the plant or the fruit or whatever you're trying to protect. Then by the time harvest comes around, you just want that stuff to be either degraded by sunlight, degraded by pH, maybe just degraded by the fact that they're washing it. I mean, unless you're making hash, no one's washing their cannabis. And if you're washing your cannabis, maybe you're doing something with the water. So God only knows. But I think the point you bring up is really important in big agriculture states like Vermont, which is there could simply just be pesticidal drift. So if there's corn and people are applying pesticides to corn in one valley, you could easily get maybe some transfer from just the wind. So, or birds, birds are in one, they're eating corn and they're shitting it out over here. And maybe, again, there's a lot of, crosstalk between neighboring farms sometimes. And you see that rising to the point of contention between wine and cannabis farms and vineyards out in California. So
you can get pesticides just drifting in the wind.
Especially if you look at those machines that those guys are using, Callie and those guys have over at the lab, that thing could measure things down to like a fifth of a ppm or ppb, which is like 3 orders of magnitude lower than ppm. Now, oh my God, you're going to be, if you just take a dollar bill out of your wallet, they'll be able to sniff cocaine off that dollar bill that was sitting in your wallet for the last week. I mean, those things, when you're sniffing things down to the part per billion, this is like taking a lint brush to a New York City sidewalk. Okay. You're going
Well,
to
I hope they
find,
don't do that because I've got like $2 on the table. I don't need that. That was
you're going to find everything at that level. So
Mm,
again, when they say like zero pesticides, well, if there's sort of like a farm that's applying pesticides over there, there could be drift, and you could basically see single digit ppb levels in your farm, even though you didn't apply glyphosate or you didn't apply, Eagle 20. The farmer next door did, and guess what? So you could tell that's a difference between somebody who directly applied Eagle 20 to a crop that had PM, because now you're going to see
mm,
much higher levels and the higher levels of ppm. But when you could see down to ppb, Caleb, holy shit, man, it's like amazing what you'll find.
mm. I took an atomic force microscopy class in college.
Cool.
It felt kind of like that. We were seeing like a graphite. I'm like, oh yeah, it's got all the topography of it. That was fucking weird. I didn't
Well, yeah,
understand.
atomic absorption is
Yeah.
is is super super cool. That they use a similar method in the cannabis industry when they do their metals analysis. They use something called ion coupled plasma, but it's the same kind of concept. You're
Oh,
basically looking at how the different metals transition with different lasers and whatnot, and look to see like how much of a certain metal is there based on the intensity of the line and everything. So yeah, it's really cool, really high tech instrumentation to give you basically one number.
yeah, and they were like, "Yo, the scanner head had like a little laser in it." They're like, "If you drop this, you might get kicked out of college."
Yeah.
But it was fun. I had a great time doing that, and it was fun. I mean, that was over my head as well, as has been most of this conversation, Mark. And I'm almost out of shit here. I know you got another show to do, and I was hoping before we get out of here, you would tell us about the Dank Hour because I've had a couple of those folks on my show, Anna Schwabi and Tess Adam,
Yeah, Anna.
who I
Yeah.
thought were just amazing guests. And it looks like you guys have a great lineup of scientists over there. And I'd love to hear your thoughts on that show, please.
Yeah. So this is London, who I met. Actually, we haven't ever met. We've never shaken hands or breaking bread. We actually met virtually over Clubhouse. Remember Clubhouse?
No.
Oh,
So I,
Clubhouse was this app. I guess it was during COVID that seemed to kind of pick up where people were stuck at home, and it's kind of like Zoom without the video. So it's just a bunch of people, a bunch of experts chiming in, and he was on a couple Clubhouse rooms that had some discussion around plants, and they started this future cannabis project thing on YouTube. And I know a couple of those cats, and they got London to start this Dank Hour thing, I think after COVID ended. And Yeah, it's just a group of panelists. They usually have a pretty interesting guest that, plays a pretty decent public role in the industry, kind of like Ethan Russo, for example, is one guest we had. We had Ian from Abstracts, he was on, and just people who are doing just really cool stuff. And then the panelists ask them questions. I think they rely on me to ask the chemistry questions and the science stuff. But I mean, me, I can talk forever. I
yeah.
love having dialogue with scientists and people who are enthusiastic, and that's just the thing about enthusiasm. Carlos Santana says enthusiasm is contagious. So if you're enthusiastic, like about what you're talking about, and you're talking about cannabis, and you're talking about, all the things you like about it, the other people around you get enthusiastic about it too. So I've seen that with work teams. I've seen that with these internet, podcasts. I'm also on something, Caleb. I don't know if you know this. It's called Hash Church on YouTube. Do you know about Hash
Yeah,
Church?
yeah. You
Yeah.
told me about that, and I watched a couple of episodes of that because I had never heard of that before. But
Yeah.
you
So
you and a guy that I helped harvest with both mentioned it, so I decided to check a little out.
yeah, so Hash Church, there's got to be about 400 episodes up there on YouTube. I know it was weird. Right around COVID time, somebody hacked Marcus's account and basically hijacked all his Hash Church content off of YouTube. But I think all the videos are there, and it's just really fascinating stuff. I mean, there's um, just discussions around making hash and discussions around testing and regulations and extraction. And Lester Grinspoon is on, and Todd McCormick is on, and Skunkman Sam, aka David Watson, and Robert Connell Clark. I ended up becoming personal friends with all these guys because we were on these episodes together. And even though we hadn't actually met, well, actually, I'd met Robert Clark, but I haven't even met Bubble Man yet. And so one of the reasons why is because he got in trouble at the border and he can't come to the United States, but he's working on that. I'm hearing he's going to make it back to the United States, but he would be a great guest for you to have on, Caleb. Bubble
That'd be
Man,
cool.
Marcus Richardson.
Yeah, well, I have the opposite problem. I can't go to Canada. I'd like to.
And here in Vermont, we're so damn close to Canada, right?
Yeah, I grew up half an hour from the border, man.
Right. Well, that sucks. Well, hopefully we'll fix that someday. And I think cannabis. They need to end cannabis prohibition altogether because whenever a plant can provide relief to humans and to human suffering, it should not only be lawful, but it should be encouraged before taking all those pharmaceuticals that we hear about on the nightly news every day with all these side effects and funny names and fake scenes down at seashores and parks playing with dogs. And let's face it, the US pharmaceutical company has lulled the publics into believing that whatever's wrong with you, there's a pill for that, right? And it's brought to you by $1 billion pharmaceutical company that's paid for by these TV ads that you're watching, and paid for by $1 billion drug insurance at $1 billion drug stores. Cannabis isn't a drug, it's a medicated herb, and it needs to be regulated as such. And I think when more people are using cannabis, less people will be using pharmaceuticals with all those side effects. And I think less people would be using recreational synthetics like Delta 8 and whatnot. Just give them unfettered access to cannabis. That's what humans want. We've always had it until last century. I call last century the cannabis deficient century. But this century we fixed that, and we're on the way to ending cannabis prohibition and making sure that humans have unfettered access to the plant, which is what they need.
Yeah, and the only other question I had was about descheduling versus rescheduling, and also you touched on the big pharma stuff, and it seemed like maybe that's the reason. I see Pfizer dumping
Rescheduling is a non-starter, Caleb. You know why? Because Schedule 3 drugs have to be dispensed by FDA registered production facilities, and there's no cannabis production facility today that's FDA registered facility, or is there dispensing done at FDA registered stuff? And look, you see what's happening down in Georgia, right? They tried to pharmaceuticalize their low THC oil by selling it at pharmacies, and guess what? The DEA says no, you can't do that. So look, cannabis is different than pharmaceuticals. They're just two different things, and there's no game for the pharmaceutical companies to play in cannabis because they can't patent the active ingredient. When things come along like HHC and HHCP and HHCA, those things need to be investigated because they're all analogs of the naturally occurring plants that should be relegated to the likes of researchers like me who want to develop new medications based on analogs of what are in the plant. People shouldn't be using those analogs until we know what kind of safety profile they have. I mean, hell, if people have access to good cannabis, they don't need access to these other things. Let these other things go back to the laboratories and the researchers so people could find out, gee, are these analogs good for anything? Maybe they're good at, curing some disease that cannabis, the cannabinoid, the phytocannabinoid, the naturally occurring ones, don't exactly work for. So we have to figure that out. And there's a lot of research to be done to figure out how we can deliver these into the body in a way where they're effective, like pharmaceutical agents, but ultimately tying it back to the plant.
Do you think that the pharmaceutical industry will ever catch up with just the people that are really good at growing plants? And that's my last question. I'm almost out of shit here, Mark, but I'm curious because I know the pharmaceutical industry is trying to, recreate Mother Nature, as it were. And I think there might be, go ahead.
So the issue is that the biologically active compounds that are found in plants and marine organisms and fungi, those are biologically active natural products, right? And we could study and we could extract those natural products. But for the pharmaceutical companies, what they need to do is they need to basically come up with a derivative of those products that has better clinical properties and better, and they have to be able to make it, but they have to be able to patent it because guess what? It costs a lot of money to take compounds through phase 1, phase 2, phase 3 clinical trials. You're spending an awful lot of money. So you need to recoup that investment by being able to take that FDA approval on your investigative new drug and is now a approved new drug by the FDA. And now doctors have to prescribe it. Now they have to make commercials for it. They have to market it. They got to do all that stuff. I mean, they have to do that on something that's not a phytocannabinoid. So when GW basically took CBD through clinical trials, it already proved what Meshulam and co-workers found 40 years ago in Brazil, which is that in a statistically significant swath of the population that gets this intractable form of epilepsy, CBD is effective more times than not, better than placebo in controlling the symptomology associated with those rare forms of epilepsy. We already knew that. Meshulam showed that back in 1980. And you know what? It was viewed as being weed. We don't care about weed. And that was before the Farm Bill and before hemp and before the CBD boom. And so if you think about it, again, the thing that GW did that was important is they basically showed through clinical trials that an active ingredient that's derived from the cannabis plant, cannabidiol, can basically be an FDA-approved drug. Okay, that right away should have unwound the Schedule I listing of cannabis, right? Because this plant is derived from cannabis. And in fact, years before, when THC, dronabinol, right, which is racemic synthesized THC, when that was approved, they should have completely removed cannabis from the Controlled Dangerous Substance Act. It's not dangerous. It doesn't need to be controlled. And think about things like tobacco, right? Which 60 milligrams of nicotine is the average dose to kill an average size human orally taken. 60 milligrams of nicotine, okay? How many milligrams are there in every pack of cigarettes? It'd be interesting to actually try to get cigarettes approved today, right? Cigarettes were grandfathered in because this country was founded by tobacco farmers, right? Thomas Jefferson, George Washington, and whatnot, who also grew hemp, but they grew a ton of tobacco as well. And they knew
be interesting to try to get
has been a big money maker since the day of the 13 colonies. But I just moved up here from Vermont from Pennsylvania, and we lived near the Lancaster, Pennsylvania, which is basically the Susquehanna River Valley. And during William Penn's Pennsylvania, that was the cradle of the hemp industry in the 13 colonies. Because what did Her Majesty, the Queen of England, need to conquer the world? Needed a navy. What do you need for navy? You need ships. What do you need to blow ships over the ocean? You need sails. How do you make sails? With hemp. With hemp? So Pennsylvania farmers during William Penn's Pennsylvania were taxed if they did not grow hemp, right? So it's great to see what the Farm Bill has done in Pennsylvania and so many other states where hemp was grown for many years. In fact, in Kansas, I think there's still feral hemp. There's still hemp that was grown for the war effort back in the 40s, and seeds have just, proliferated in the environment. So you could still find swatches of feral hemp in the middle of Kansas, of all places, which has the worst cannabis laws.
I do want to slap these comments from Rodney. Cheers. Yeah, Rodney, thanks for jumping in there. On the low end, a single cigarette may contain about 6 milligrams of nicotine. On the high end, about 28 from what I've found. Hey,
yeah. Rodney. So that's, remember, you're smoking that. And so you're drawing that into your lungs. And the other thing is that there's so many nitrogen containing compounds in cigarette oil compared to cannabis oil. Cannabis oil is remarkably safe, right? I mean, you ever hear of anyone dying from cancer from taking cannabis oil? No. But cigarette oil, oh my God. And when you burn cigarettes, you make nitrogen containing compounds like nitroxides and nitroso compounds that are just absolutely fucking toxic as hell. So, yeah, it's just night and day when you compare the toxicity of cigarettes to that of cannabis. It's tobacco, I should say.
Yeah, and I see some people also talking about, and we're gonna get out of here in a minute, but since you mentioned it, I see some people say, "Hey, we should regulate this like alcohol." I've never felt like that because I feel like alcohol is a totally different thing. How do you feel about that idea? Regulate cannabis like alcohol?
Yeah, so like alcohol, tobacco, and firearms, right? ATF, right? Alcohol and tobacco are both deadly, right? Alcohol is deadly. In fact, I have 5 friends, count them, 1, 2, 3, 4, 5, no longer walk on planet Earth. You know why? They decided to drink themselves to death, right? 5 friends that I grew up with, right? No longer here because they consumed alcohol, which was legal. They legally killed themselves by drinking themselves to death. And I'm not the only person who knows that alcohol tears apart families. It creates abusive situations where people get abused. Alcohol, and I like a single malt scotch. Occasionally, I like an IPA. I have the same 12-pack in my refrigerator that I've had for like 4 months now. So, I mean, I'm not a big drinker myself, but I know a lot of people who do. And I see a certain ugliness about alcohol that I don't see with cannabis. So I don't think they're equal at all.
And you drink an IPA. I almost gagged right there. Terrible. That's the worst thing you said in this whole interview, Mark.
Oh, man. Well, it's just a matter of flavor. I mean, some people like IPAs. I also like a good stout, but I know one thing with stouts, if I drink more than 2, I'll get heartburn. But I like a good red ale. I like a good, I like a hoppy IPA. I mean, I like microbrew. I do not like Budweiser. I do not like mass brewed produced beer. I don't like it at all. I can't drink it at all. I can't drink a Miller. Can't stand a Bud Light. That to me just tastes like cat urine.
I'm going to do another shameless slap. Dr. Mark Scialdone. Mark, I'm going to pull myself back up here because I'm out of shit right now. I want to thank you for your time. This has been a fascinating discussion here. And I believe that, I always leave a last word for my guests. So, yeah, I got nothing else. Something about watch the movie Concussion. That's in my notes, but I don't think that's important.
Well, okay, that's a good point to bring up. So, so all cannabis use is medical. I know you've heard it probably before, that there's no such thing as recreational cannabis use, because the cannabinoids act on a particular set of receptors in our body. So literally, we are hardwired for these molecules. But the other thing that cannabis does that I'm not sure, I just, anecdotally, I'll say that cannabis, because the molecules, the cannabinoid molecules themselves, are antioxidant and have anti-inflammatory properties. I do believe that our bodies have evolved ways to hold on to these molecules for as long as we possibly can. That's why it takes so long to pass a drug test, a urinalysis test, because the molecules themselves don't like water, right? They're not water soluble, right? You ever try to clean your bong out with water? Doesn't work too well, right? So they're fat soluble. So that means they're stored in not only fat tissue, adipose cells themselves, but they're stored in the fatty tissues in your body and in your organs, and your fatty tissues like in your liver, and your fatty tissue in your pancreas and your brain. I don't have, again, any experimental evidence or clinical evidence to show this, but I believe that, cannabis use and putting those molecules into those tissues of the body helps prevent free radical formation associated with aging, and free radical formation associated with cancer. And I do believe that, again, our bodies have evolved mechanisms to hold on to these compounds, that these compounds in the future, we will really understand them not so much as drugs, but more as part of our nutritional intake, because these molecules act in our body and help protect our body. I believe that all those fatty tissues in your body after you use cannabis are now protected from free radical mediated damage, because you have antioxidant molecules in there that can act as sacrificial lambs versus your DNA, versus your tissue. So I'll just leave on that, all cannabis use is medical, whether we understand it with our current knowledge of the body and of science now, or whether we understand it, it's going to take another 20 or 30 years. But somewhere out there, we're going to understand the value that these compounds have in human consumption, going beyond just agonizing the CB1 receptor to feel that high we all know and love. So feeling high is medical.
Why do you think I still look so young, Mark?
Well, people say the same thing about me.
One more shameless slap here. Dr. Mark Scialdone. Mark, do you have any slaps, shameless plugs, or things you're working on? I'd like to give you the last word here before we check out. Thank you so much for your time tonight. So obviously, you kind of blew my mind for about half an hour there, where I might have looked like a fucking idiot. But
go see Fish. That's my advice to everybody. Go see the band Fish. They are the most amazing band in the land. They're here from Vermont. I'm going to be going to their concert here the week after next in Madison Square Garden in New York City. So my advice to everyone watching this is go see a Fish show.
All right, I'll go with you, Mark. Fine.
Peace.
I'm Caleb Teskey, Dr. Mark Scialdone. Have a great show with the Dank Hour later. And remember, the devil's in the details, and the details are in the fine print. Peace.